For Lesson 4, we'll be moving on to solving one-step equations that involve multiplication and division. Just a couple of notes and reminders about notation. Remember that multiplication can be written as a coefficient next to a variable with no symbol in between, maybe like 2a. We have that invisible multiplication in there that we don't write. Division is often written as a fraction. For example, x divided by 2 would be x over 2. Take a look at these next three equations here. We have 5m equals 50, n over 4 equals 6, and 1/5 p minus 4/5 equals 2 3/10. Let's decide, are any of these possible to solve in your head? Are some of them more difficult to solve in your head? Are some of them impossible to solve with the information that you have right now? So go ahead and you can answer that question right here and say which of these variables you're able to determine without having seen the lesson yet today. Okay, so chances are this one was the most likely. M was the most likely that you could find in your head. You might have figured out n with the fraction, but this last one would be very difficult to figure out with the information that we have right now. And it's not something that you could guess to figure out what p is going to equal to, because we have so many fractions and crazy things happening there. All right, so we do have some steps that we can learn to follow today. So just like with adding and subtracting, to solve equations, we must undo each operation in the equation. To do so, we use the inverse operation. This should sound familiar, but now the inverse of multiplication is division. And reverse that, the inverse of division is multiplication. At this point, I just want to recommend that you try not to use the word opposite here, because opposite as a math word really applies more to adding and subtracting. There isn't really a word other than inverse that I would recommend for multiplication and division. They're inverses of each other. All right, so let's look at some examples. And I just want to remind us that we're focusing on the process and the steps here, not just on the idea of getting the final answer. So pay attention to the process, the step-by-step. Don't just worry about, oh, I can immediately see the answer is 5. That's not what we want. We want to worry about the process, the steps. All right, for number 1, draw your line down. Look for the variable. It's an a. The a is being multiplied by 3. Do the inverse. So draw a fraction line underneath on both sides, and we're going to divide by 3. Why 3? Well, if we do 3 over 3, or 3 divided by 3, that makes a 1. Meaning we just got 1a, 1 times a. That's the identity in multiplication, so we don't write it. It's just a. It's the equivalent of adding 0. A equals 12 divided by 3, which is 4. So our goal for multiplication and division equations is to make 1, the identity. For number 2, draw your line down. There's an h. It's being multiplied by 6. Divide on both sides by 6. Why? Because 6 divided by 6 cancels out because it makes a 1. 1 times h is really just h, so I don't need to write the 1 times. 60 divided by 6 is 10, so h equals 10. Number 3, maybe not as obvious the answer on this one. Draw your line down. X being multiplied by 0.5 or by a half. Do the exact same thing on both sides. We see multiplication, so we're going to divide, doing the inverse operation. Since we still have 0.5 over 0.5, doesn't matter. It's still a 1. So this is 1x. 1 times x is just x, so I'm not writing it. X equals whatever 10 divided by 0.5 is. Either you put that in a calculator or you do that math out. Whatever you end up doing, you're going to get the answer as 20. Because if you fill it back in, half of 20 is 10. All right, draw your line down. I see the variable p, and it's being multiplied by a 1/4. It's going to look weird, but we can still write it as a fraction, like this. It looks weird. So on this side, it doesn't matter. That's still a 1. 1/4 divided by 1/4. Anything divided by itself makes a 1. 1 times p is just p. I'm not going to write the 1. P equals whatever 9 divided by 1/4 is. And so I just changed this fraction notation to look like a division problem because this is how we write dividing fractions. I'm going to go ahead and do keep, change, flip. So put a 1 under the 9, keep it, change to multiplication, and then flip over your 1/4. That's going to be 9 times 4, which is 36, over 1. So our answer for this one is just p equals 36, meaning 1/4 of p, 1/4 of 36 is 9, which is true. And here are our answers for 5 through 8. You can pause here if you'd like to copy them down. Let's take a look at division equations. Again, we're focusing on showing the steps, the process, not just on getting the answer. So try to follow along with the process step by step. All right, number 9. A divided by 3 equals 5. Draw your line down. The inverse of dividing by 3 would be to multiply by 3. So I always write it kind of up at the top, 3 times, and then 5 times 3 over here. This 3 times A divided by 3 is going to do exactly what happened in the multiplication equations. Those make a 1. 3 divided by 3 is 1. So 1A equals 5 times 3, which is 15. We know 1 times A is just A, so that A is by itself. Draw your line down for number 10. V divided by 7. Let's do the inverse and multiply by 7. 7 times 7. If you're not convinced, 7 times V over 7 would simplify to 7V over 7 equals, and then on the other side, 56. Now maybe it's more obvious to see the 7 over the 7. 7 divided by 7 is 1. So this is just 1V, or V, equals to 56. Okay, number 11, draw your line down. K divided by 9 equals 0.5. So let's multiply by 9 to undo that division by 9. Both sides to keep it equal. So again, if you want to see it, this is technically 9K over 9. But you don't need to write that. It's just canceling out because it makes a 1. So 1K, or just K. And then we need 0.5 times 9. So half of 9. That's going to be 4.5, or 4.5. And number 12, draw your line down. This time the P is being divided by 2.5. Multiply by 2.5 on both sides. 2.5 times P, then divided by 2.5, those are going to make a 1 because we did the exact same thing but inverse operations. 1P is just P, and now when we multiply this, we can always show our work off to the side here. It's really just going to end up moving the decimal point. So we get 0.25 as our answer for P. All right, I'm going to show the next ones without talking through them. And here are the answers for 13 through 16. So you can just copy down those steps, or you can try them on your own and pause here to check your work. Last up here, let's choose one of our challenge equations, and we're going to look at the steps. Feel free to solve the others if you'd like, but we're not going to go over them in the video. Let's take a look at number 17. So in number 17, I see that we need to combine like terms because we have multiple terms with x's, and then we have some other terms that are just constants. So let's combine them. A 3x minus an x would be like 3 minus 1, so 2x. Plus 5 minus 5, that makes a 0. So those actually cancel, and it equals to 15. So draw your line down. On both sides, divide by 2, because we see multiplication by 2. That makes a 1. 1x is just x, and half of 15 would be 7.5. And just one final thought to leave you with here. We've talked about inverse operations, adding and subtracting our inverses, multiplying and dividing our inverses. We learned a new operation this year, exponents or powers. That has an inverse as well. So think about what that might look like. For example, if you have 7 squared, meaning 7 times 7, how could we undo? What would be happening if we tried to undo an exponent? Just something to think about.